This is AWR Microwave Office series for beginners. In this video, we will learn how to simulate simple current source circuit using Cadence AWR Microwave Office and understand the effect on measurements by varying the load in the circuit. So let's get started. So in the first step, we are going to run AWR design environment and create our first schematic. Right click and click over new schematic. In this case, since this is a current source circuit simulation, so we are going to name it current source circuit and click over create button. Now to place the elements on this schematic canvas, we have two ways to do it. One is from this element browser. Another one is we can go to library by pressing Ctrl L on our keyboard. And here we have to type DC current source. So let's type just DC and here we go. And click over OK button. We'll place it somewhere here. So as we all know, like ideal voltage source manage to keep the supply a constant voltage to the circuit, right? Independent of whatever will connect at the load side. Similarly, ideal current source will maintain a current source or constant current source in the circuit independent of any load. All right. Next, we are going to add the loads here. So as of now, we'll just place one resistor. Press Ctrl L and type res and we'll select closed form of resistor and place it somewhere here. After placing the resistor, we know we have to add the ground as well on the negative terminal and the current will be flowing in this direction. All right. And then make the connection. The current units are in milliamps. If you want, you can change it by going to project option, go to double click here on project option, global units, edit units, and here you can change it to amps. So as of now, it is 0.01 amp current source. Let's make it 1 amp. There we go. And we have 1 ohm of resistor. Then what will be the voltage? As per Ohm's law, it will be 1 volt, right? But before running the simulation, we have to annotate this circuit. So we want to simulate this for voltage. So that means this time we don't need to annotate for current. Now to annotate it, we have to just select the schematic, right click, add annotation. And for voltage, we have to select DC VA. So here you can see the DC voltage for all the nodes. And click on apply, OK. And next we are going to run the simulation. To do that, we'll just click over this analyze button. We can see all the information in the status bar. So you can see that this current source is continuously supplying 1 amps of current and we have 1 ohm of load. So that means the voltage will be going through across the load will be 1 volt. Now let's say if we want to change the load, we can simply copy and paste. So first we'll just delete this wire, Ctrl C, Ctrl V to rotate it, right click and just connect it. So now we have 2 resistors in series. Just drag it here. So then now what will happen? What will the voltage across it? In series, the R equivalent will be 2 ohm. And as per V is equal to IR, there will be 2 volt of voltage across these loads from this current source. So let's reanalyze. And here you can see we have 2 volt of net equivalent voltage, where we have 1 volt across R1 and 1 volt across R2. So similarly, you can just play along these values. So let's say instead of just adding these series resistors, I'm going to add parallel resistors. So press Ctrl L on your keyboard, just type RES, and here we'll have closed form of resistor. Okay, so one more thing I wanted to show you. Let's say we have already placed the component and we wanted to rotate it. So you can just select rotate. And here you have to draw the axis along which you want to rotate it. So this is how this rotation tool works here. So you have to just draw the angle and just select the components. So Ctrl C, Ctrl V. Here we have 2 components connected parallelly. Next we are going to add wire. Now we have R equivalent is 0.5 ohm. So that means the the voltage across this equivalent load will be 0.5 volt, right? So let's rerun the analysis, and here we go. So similarly, you can just play along with these load values. You can add capacitors, inductor, and just see how it is behaving with current source, and you're getting the exact simulation results as per your calculations. In the next video, we'll talk about how to model an element in AWR if it is not available in the library. So as of now, we have all these components available in the library. Now what we'll do if we have to create our own model. So we'll discuss that in the next video. To save this project, we'll just go to File and click over Save Project. In our case, I'm going to save it on desktop. Let's name it Current Source and click over Save button. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.